right, folks, welcome to BarleyBin Live. So we're really excited to be here. We're at the Dam Smokehouse in Nipawin. I don't know about you, but my first time here, it was an excellent meal. So shout out to the staff here at the Dam Smokehouse. Also want to give appreciation to everybody who took time out of their schedules to be here. We've got speakers who've come from a long ways away, Saskatoon, Indian Head, and Lacombe. And we've got everybody in the room here tonight, so appreciate you taking the time to come in and hear a little bit about barley tonight. So I'm going to give a little bit of background on SaskBarley before we get going. Aaron's going to be our first speaker, but I'm going to just give a little bit of background on where SaskBarley's at. So introducing myself, I'm Mitchell Japp. I'm the Research and Extension Manager for SaskBarley. I've been with them for 4 years and really been enjoying the culture and the work at SaskBarley. We've got a lot of different things going with the research program, and BarleyBin is one of our key extension activities that we do. We do have several others here from SaskBarley tonight. We've got 3 board members, Gord Mullenbeck, Matt Enns, and Chad Ferguson. So put your hands up and be seen by those in the room tonight. We do have 3 other board members who weren't able to make it tonight: Zenith Fay, Morris Berry, and our chair Cody Glenn. Cody really wanted to come, but it's a long drive for him down in southwest Saskatchewan. Jill McDonald is our executive director, and Sarah McSimmons here. Both are instrumental in getting rolling for tonight. So thanks out to you guys. And thanks also to our hosts here at the Dam Smokehouse, Farron and crew. So SaskBarley has been really committed to investing into research. With our previous strategic plan over the last 3 years, they made a commitment to be at least 65% of our annual expenses into research, and we've well exceeded that. The closest there was last year, 22-23, it was at 66%. And that was only the reason it was that low was because of a delay in signing a major agreement. So it's continued to be very good for last fiscal year, 23-24. It'll come in around 71%, which the new graphics will come out for our AGM coming up in January. So it'll keep our 3-year average at 72% is going to extend, and it's going to be right in that 72% range over the 4 years. We've got a new strategic plan that continues that commitment, probably targeting a little more closer to the 65% level investment into research to give room for more things like market development. We've invested a lot of our dollars into variety development, but getting variety uptake is also really important. And so SaskBarley's done a fair bit of work directly and with the Canadian Malting Barley Technical Centre and partners at the Brewing and Malting Barley Research Institute to help transition to some of the new varieties. So we're starting to see that transition period here right now. We've got a lot of uptake of varieties like CDC Fraser, AAC Connect, CDC Churchill, and starting to grow some interest as well in the I think the newest malting barley variety, AAC Prairie. So those are some really promising varieties. I know all the directors are growing at least some of those varieties, so they can give you some direct feedback. And we also have some longtime supporters of the BarleyBin Live event in the room from the seed companies. Lauren Wensley with Seacan, Charlotte Greenshields with Cantera, and Colin Tanner with FP. So if you've got questions about varieties, those are good guys to talk to. And so, as I mentioned, this is one of our key premier extension events, but we do have a number of other extension channels as well. We've got our monthly e-newsletter, the magazine, so there's some on their tables if you didn't get one in your mailbox already, or you can access it online. And we're on a number of the social medias like Twitter and Facebook, so I encourage you to connect with SaskBarley through any of those avenues. But that's, like I said, just a little bit about SaskBarley. I'm not going to go right into the details, but we're going to get started on BarleyBin Live. And so it's a little bit different from most of the extension events that you may go to. And so the idea of BarleyBin Live came out of a what-if scenario. If you're familiar with what-if scenarios, It's imagine you've just, come across your favorite barley researcher, coffee shop, at the bar, and you've had this burning question that you've been wanting to ask. And so you run into your favorite researcher and they're there, and it just so happens they've been thinking about that question too, and they've got an answer for you. And so it's about generating the conversation that could come out of that kind of environment in a cafe or a bar where you can have a really good conversation. You can get the information you want via some back and forth. And so the way we do this, we're going to pose a couple of questions to each of the speakers, and then the floor is open for you to ask some more questions. So there will be a brief presentation from each of the speakers tonight, and then one at a time as we wrap up one speaker, when we can have that conversation. And when the conversation winds down, we'll move on to the next speaker. So we've got 3 speakers here tonight. I alluded to them before. Dr. Aaron Beattie from the Crop Development Center at the University of Saskatchewan. Dr. Kelly Turkington, who will wrap things up tonight, from Agriculture and Agri-Food Canada in Lacombe, and Chris Holzapfel from IHARF, Indian Head Ag Research Foundation. So we've got pen and paper on all the tables, so grab it if you want to take some notes, or if you just want to sit back and enjoy. This is BarleyBin Live. First topic tonight is I think one that'll generate some excitement. New variety acceptance is sometimes a little bit slow in the malt industry, but as I mentioned, we're at a transition period right now. I think even on the feed barley side, which I didn't necessarily expect, we've seen a slow transition there too. The current top variety in the feed world is CDC Austenson, and it's been there for a long time, but it's been a tough variety to top. But I think Aaron can probably talk a little bit about some varieties that are very close to market or just into market that I think have the potential to topple CDC Austenson from the top of the feed market. So, first question to Aaron. We've got a map of the barley genome. Gene editing has recently had the reins loosened by the Canadian Food Inspection Agency on its use in breeding in Canada. What are the possibilities that emerge for barley from these recent developments, either individually or collectively? What's your perception of the market risks of using it? And how would barley fit in the overall crop choice for growers if we don't use the tools available? I'm going to ask the second question as well, just so Aaron can have the mic and he can roll with it. So Aaron, you see the barley line's performance from the initial cross to the Western Canadian field trials just leading up to registration. At what point do you get excited about a line or new variety? And what new traits are you seeing in the pipeline?
Okay, so question 1 here. So I think this is a huge question, and Mitchell said I've only got 10 minutes for each one. So I probably need to give you a little bit of background just to kind of maybe set the stage on this. So as you may or may not know, in the last 25 years, we've heard a lot about sequencing of genomes. And the first one you might have heard about was the human genome. So that probably goes back about 20 years now. The crops sort of followed on from those developments that we learned about how to do it in the human genome. And so barley, about 2012 was the first year that we got our first sort of look into what the barley genome looks like. And that was in one particular variety, US variety that was called Morex. So quite an old variety, but it was the one that got chosen to do the sequencing on. Since that time, there's been quite a number of other genomes that have been sequenced. In fact, just in the last few months, there was a consortium of workers that released 75 genomes. So that means 75 different barley varieties have been now sequenced. And so that's a big body of knowledge that we potentially now can take some use of. So if I kind of step back in time before we had all this information, just to give you a bit of an example of how we maybe go about things and how these genomes can maybe help us out. Since Kelly's in the room, who's a pathologist, I'll use sort of him as an example. So if I was interested in scald resistance in my barley variety 30 years ago. Really, the only way that we could do that is I would have to send Kelly some of my breeding material. He would grow it out in a field. He would inoculate it with the pathogen that causes scald, and we'd figure out pretty quick if we had resistance or not. So as we kind of move forward in time, we were able to use some of the tools we had at the time, genetic tools, that would allow us to identify roughly where those genes are in the barley genome. We didn't know exactly, but we had an idea. And so if you hear people talk about molecular markers, that was sort of the technology we have. A molecular marker basically tells us roughly where in the genome a particular gene is that controls a trait. So if I was, again, talking about scald resistance, we'd have markers linked to those genes, but they weren't perfect. So there was an error rate. So if I was selecting a barley line that had a marker that was linked to scald resistance, I would be pretty sure that it actually did have scald resistance, but there might be a 10%, maybe a 15% error rate, which would mean actually it wasn't resistant. So with these genomes now, we can get very detailed in terms of understanding which genes control what traits. So now my error rate goes down to almost nothing if I can figure out exactly what gene is controlling the traits. So with these genomes, we can start to, with some background research, figure out what genes control what traits. And as a breeder, I can start to incorporate that information into how I do selection. So I don't necessarily now maybe need to send all of my material to Kelly's nursery. I can do some work selecting for these traits based on these markers, which are now very accurate because they are actually now inside the genes that control the traits. And so moving forward, as we kind of pick new traits that are of interest, maybe it's lodging resistance, maybe it's malt barley quality, we now have 75, 80 different genomes now that we can look at to understand how much variability there is for these characteristics. So again, if I was interested, say, in protein content, I might be able to narrow down the region pretty roughly using some of our old tools. But now with all these genomes, I can now say, okay, well, we think it's in this part of the genome. What genes are in that part of the genome? I can look across these 75 different barley varieties. And if I measure protein content in them, I can pretty quickly determine, based on the genes they have and the variation in those genes, if I've actually got the right gene. So again, as a breeding tool, this is very useful for me. And we already are making use of this information in our program. So that's kind of the background on the barley genome. And where gene editing comes in is that gene editing basically relies on having information about the genome. So if you didn't know anything about the barley genome in this case, gene editing basically is a tool that's unavailable to you because it relies on knowing two things. It relies on knowing the sequence of the genome, but it also relies on knowing what genes control what traits. So again, if I was looking at if I knew a particular gene controlled a particular trait, I can use gene editing to alter that trait, hopefully in a beneficial way. So you still need to do a lot of background information or background research to figure out what genes are controlling what traits. Gene editing then may allow you to alter that gene in a way that is beneficial to you. So gene editing sometimes gets played up as this magic tool that's really going to propel us forward in all types of crops for all types of traits. I probably don't see it quite that way. There's still a lot of background research required before you can actually use that tool. So if a trait comes along that we're interested in, or even some of these older traits like lodging, if we don't understand the genes that actually control those traits, gene editing has no value to us at all. The other thing about gene editing is it tends to be most useful for traits that are controlled by one or very few genes. So some diseases fall into that category, some quality traits fall into that category. But for the most part, yeah. Better? Same. So most of the traits that are of most interest to us, yield, probably FHB if we were talking about barley, these are traits that are controlled by a lot of genes with very small effects. So gene editing is probably going to have no impact on those kinds of traits. And when you look through the literature about what traits have been brought forward and commercialized. They're things like sulfonylurea resistance in canola. It might be increased fiber digestibility in alfalfa, which is a single gene trait. In crops like apple, I think that's got it, yeah. I think in crops like apple or potato, they have these so-called non-browning characteristics. Again, these are single gene traits. This is where we're seeing gene editing having its initial impacts, and I'm a little doubtful that it's going to have a lot of value to us as we move into the more complexly inherited traits. So it's an interesting tool, but it's just that. It's just a tool. And it kind of takes over from what breeders have been doing for a long time. So it's sort of the precursor to gene editing is what we call mutagenesis. And mutagenesis is just this simple way that we used to alter plants to try to find characteristics that we cared about. So for example, if I wanted to find a semi-dwarf barley and I didn't have it, I might take a bunch of seed of my favorite variety. I might treat it with some sort of chemical agent that causes mutations within the genome, and then I would go out and look for shorter plants. So I didn't need to know what genes controlled that trait. It's basically a shotgun approach to it. So you know that many of the mutations that get induced are going to have no effect on the trait that you're interested in, but some of them will actually impact it. So gene editing is just a little bit more of a precise form of mutagenesis. The caveat being you actually need to know what gene you're changing. So it's got a good side, it's got a bad side to it. So maybe that leading into the second question, are there still market risks? So there's been a lot of debate about initially where gene editing fits into the whole genetically modified crops discussion. And so some recent changes with CFIA has basically said that gene editing should be thought of as basically like mutagenesis. It's not quite a conventional breeding tool, but it falls into that category of tools that breeders have at their disposal, which will get regulated a little bit differently than a genetically modified crop. But there are caveats to that. And so Canada, this is where there's a little bit of background information required. So in Canada, we've never really regulated a crop based on how it was created. So we have a term in Canada that we call plants with novel traits. And basically that's just saying that if a plant that you create through breeding, no matter what the process, is significantly different than what's already out there, then they're going to call that a PNT, and it's going to fall under some regulation where they look at how the impacts or the potential impacts on food safety, feed safety, and on the environment. And so that definition is troublesome because you may not always know what is going to be captured by that PNT description. So to give you an example, about 10 or 15 years ago, we had done some work, or my predecessor had done some work, where Brian Rosnagel had created a new barley that had altered levels of a compound in the seed called phytate. So phytate is just a storage form of phosphorus in the seed. This was done through traditional mutagenesis. But CFIA flagged it as a PNT because the amount of phytate in that seed was very different than sort of normal barley. So that would have sort of kicked off a long round of assessment both for environmental and food safety, which is probably a 10 to 15 year process. You're talking about tens of millions of dollars there. So even though gene editing isn't quite the same as transgenics or genetically modified organisms, there's still the potential that if you create something with this technique, it could still fall under this PNT category, which has always been there in Canada. So it's a little bit better than genetically modified organism because those automatically fall into being regulated. With gene editing, it really depends on what you've done to the plant there. So that's maybe a little bit on sort of what it means. And in terms of market risks, again, now this is just where you're getting into the thinking about, well, how are consumers going to feel about this whole technology? And so in the science community, we may feel that there are meaningful differences between a genetically modified organism and something that's been gene edited. My sense, if you talk to people who are not science-oriented folks, is that they're not going to really see a difference between these two things. They're going to generally see that some kind of manipulation has happened. And if this change that you've put into the plant doesn't really benefit a consumer directly, it's just as easy for them to say, no, I don't want that. So I still see a lot of market risk associated with this. And I think the barley community in particular, especially the malt side of the industry, being quite a conservative industry, they're always going out to their customers, the brewers, and sort of soliciting their opinions on these sorts of topics. And I don't think gene editing is really going to be much more of an appealing topic to them than genetically modified crops have been. Because they're going to be worrying about their consumer perception. And that's a hard sell. I mean, I think even if you're talking about a trait that may improve this whole big topic of sustainability, where you think, okay, well, maybe there'll be a play with the consumers. If you can say I can grow that crop with less inputs, maybe there's a sell there. I'm still not sure if that's a strong enough pull from a consumer point of view. And just to give you an example of that, in Canada, there's a company called Okanagan Specialty Fruits, and they've created this line of apples which they call Arctic apples, and basically they're these non-browning apples. So that basically means if that apple gets banged or bruised somewhere along the way between harvest and when it reaches the store, normally that's going to cause some browning. Consumers tend to shy away from apples that are browned off, even though there's nothing wrong with them. So there's a huge food wastage component to the apple industry. So these non-browning apples are trying to deal with that eye appeal, which would prevent consumers from just throwing away or not purchasing these apples. They haven't, and so when the company started down this path, they talked to consumers about this, saying, like, if you had a genetically modified crop that was dealing with this issue, and they told them about the wastage, is this something that would interest you? And at the time, they got fairly positive feedback on it, but if you look at where that's gone in the market, it's a very small uptake of that product. So there's at least in my mind, it's an example of probably a great idea, and it saves a lot in terms of food wastage, but the uptake, because people know it's genetically modified, has been extremely small. And so I still put gene editing into that same pool, at least within the general public's mindset. So I still see market risk for using this technology. And then just for the last point there about what happens for a barley fit if we don't use it. Again, like I said, I don't think it's a game changer technology to start with in the first place. There are other ways we can get to the same point using other technologies which are maybe less controversial. So I don't see it necessarily as a negative if it's not being actively used to produce varieties. We certainly use it. We use it in our own program to study genes in barley so we know what they do. Our strategy is to do that and then go look for, once we figure out what it's doing using CRISPR, we can go out into the natural germplasm pool of barley and try to find basically the same characteristic. That's kind of our approach on using it. So it's a great research tool. It tells us a lot about what's going on in barley, but then actually, taking that information and translating it into varieties, we've got other ways that we can basically go about that. So that's kind of my quick take on CRISPR there. Do you want me to do question 2 at the same time here? Okay. Okay, so again, maybe a little bit of background on this one. So in Canada, it's pretty typical for a variety to take probably 6 to 8 years within a given program to kind of make its way from initial cross all the way to something that a breeder thinks is good. And then tacked onto that in Canada, we have a 2 to 3 year registration process. So basically that's a system where, depending if it's malt or feed, the barley is grown across Western Canada in a cooperative, very public system. And at the end of those 2 or 3 years, the varieties or the potential varieties are assessed on their agronomic performance, disease, and their malt package. It's voted on. Essentially, it's voted on by a team of experts that cover the entire barley industry, pathologists, breeders, cereal chemists. And if that potential variety is deemed to have merit, so merit meaning is it better than what's already out there that farmers already have access to, then it can be commercialized in Canada. So altogether, that's maybe about a 10-year process. So when Mitchell asks, at what point do I get excited about a line or variety? That's probably at least it. So if I was to say that, in our program, maybe it's 6 years that it takes from cross to finish, probably around year 5 would be the first time I might start thinking about a line having some potential. It's at that point in the breeding process where we're actually able to get some yield information on it. We're actually able to grow it outside of Saskatoon in a number of the provinces that neighbor us, so we get some idea of adaptability. And then if it's a malt variety, that's where we're going to get some sense of its malt potential as well. So, but that's early days. It's 1 year, and as you know, year to year, you can't really rely on that being very predictive of what's going to happen the following year. So the very last year in our program, we get it out on a few more acres, a few more fields. And then, the excitement can build at that point. So that's probably about when you start to get an inkling if something has potential. Probably more often than not, you were wrong. And the subsequent years will show you that it really wasn't that good. But when I look back at the varieties that we have now and when I started sort of making a note about them, that's probably about typically when that was happening there. And then in terms of new traits in the pipeline, new traits are hard to come by that really sort of wow people. So probably, we're talking about improvements of traits that are out there, or at least putting them all together into one package. But one trait that I would maybe mention here, and it's come up in the last few years, but certainly if you're a malt barley grower, you've come across this issue of pre-harvest sprouting being a big issue. And so if you're growing some of those higher enzymatic varieties like Connect or Fraser or Prairie or back in the day Metcalf, those varieties would have had a little bit higher tendency to sprout on you compared to, say, a Copeland, or maybe these days you'd think about a Churchill. And that just has to do with the enzymatic potential of those varieties. So probably if you're growing a Copeland or Churchill, you're probably in a bit of a safer zone in terms of not seeing quite as much pre-harvest sprouting for the same amount of rain or humidity that you may if you were growing one of those other varieties in the next field. So one of the things we have been trying to work on is in those higher enzymatic varieties is trying to identify that really high level of malt quality that you would come to expect with those varieties with tolerance more like Churchill or Copeland level. So we've got a few different ways that we do that, and I think right now we've got some material, especially one line in particular in the co-ops, that's looking like it's captured that combination of traits. So I think, down the road when we're sort of had our fill with the current set of varieties, this would be sort of the next one that might come along and entice growers saying, okay, well, if I'm already growing those high enzymatic varieties, maybe it's worth switching over to this one because I may not have to deal with quite as much pre-harvest sprouting as maybe I have been in the past. So that's probably the one new trait that I see coming along, and we're maybe pretty close to having that out in a variety that has got everything else attached to it there. Yeah. So maybe I'll leave it there. It might be close for time, but if you've got questions, I'm happy to answer them now or later if they occur to you later on. So basically it's a matter, you're right, it's just combining, when I look back at the material that we got this from, it was a variety that had sort of more of that pre-harvest sprouting level of a Churchill, Copeland, with some higher enzymatic. So it's just a matter of combining those things and then screening for it. So what we try to do in terms of screening for it every year is we try to harvest a site that's sort of in their ideal conditions, so it hasn't been rained on prior to harvest. We don't obviously always get that every year, but when we can. And then to leave another field as long as we can and hope that it gets a little bit of rain before harvest. And so if we have lines that are being grown under those two conditions, we can actually look at how that rain has impacted the line. And so those lines which are impacted less by that rain event, that's essentially how we select for this high quality plus pre-harvest sprouting tolerance. So it's a matter of just trying to put parents together. We haven't really tried to study this in detail in terms of what's going on genetically. We know that there's a couple of regions in the genome that do have some connection to pre-harvest sprouting, but in the past, those genes have been causing too much dormancy. So basically, maltsters are pretty picky on this point. They want to have stuff that they can take off the field relatively quickly and malt it within a couple of weeks. They don't want to have to wait till Christmas to malt it. So what we're finding is that some of the genes that induce some level of dormancy or pre-harvest sprouting is too much, and you're having to actually wait several months before you can actually malt them. So it's kind of one of these things where it's just, again, like I said before, it's not a sort of a single gene trait. It's probably a whole lot of things going on in the barley there. Can I say that I've been part of a variety that's come along right now? Yeah. So Churchill would be one, Fraser as well, and then on the feed side would be something like Durango. Yeah. And if you do forages, Renegade would be the one. Yeah. And if you do Holzapfel, there'd be a few in there too, but not too many people grow Holzapfel. So. Yeah. Cool. Easy crown.
All right. Thanks very much, Aaron.
Yeah.
Our next topic for the night is, I think, a fairly new one to barley, plant growth regulators. So chlormaclot chloride, or manipulator, as you may be more familiar with, was registered for use on barley in 2020, and then trinexapac ethyl, or Modus, the following year in 2021. So since then, a lot of the province has really been in a lot of moisture stress, maybe not quite so much up in the northeast part of the province, but I think even 2021, between the combination of moisture and heat, it was probably a little too stressful for plant growth regulators when that products first came on the market. So I think probably northeast Saskatchewan, east central Saskatchewan, maybe north central. Those are prime target areas for plant growth regulator use in barley. It's high production areas, high rainfall, and I think it's going to be a spot where we start to see adoption of those tools to manage lodging in barley, and even the height a little bit. So Chris at IHARF has been working with PGRs since the early 2010s, I think, in wheat, and then has rolled into it in the last few years in barley as well. So Chris has a lot of experience there. He's got a lot of experience in field research in general, been at it for 25 years between grad school and doing his work at IHARF and some stints at Ag Canada before that. So he's got a lot of experience and certainly a lot of expertise in the area. And so I encourage people to engage and ask Chris some questions as we get rolling. But I'll start with the ones that we posed to Chris. So as I mentioned, PGRs have only recently become options in barley, but you've had several barley projects at IHARF recently that have included PGRs. So up until 2024, what was your perspective on the benefits of a PGR use in barley? And then 2024 has been a very different year. We had a lot more moisture, a little different kind of growing conditions. What's your perspective now? Has it changed? And I'll roll into number 2, and then you can go with your slides and let loose. So you led a project for SaskBarley. It was co-funded by Adopt with the Ministry of Agriculture. This project was initiated to compare crop safety and efficacy at reducing lodging. So how did the treatments look at IHARF in 2024? And if you can, comment on beyond the Indian Head location. So with that, we'll give it to you, Chris.
Perfect. Alrighty. So I guess we'll just kind of jump ahead here a little bit. I had just more or less repeated Mitchell's questions, but just to get us started, I think on that first one, which was coming up to 2024, what was my perspective? I am going to show you a fair bit of data, but some that I'm actually not going to present. We do a lot of industry work as well with iHarf, so I did actually have my hands on some of these products ahead of registration, and a little bit underwhelming. I think maybe 2017 we did some work with a range of rates with manipulator on barley, and it was kind of when we first went from that stretch of wet years into not drought, but just a changing in the weather patterns going from 2016 to 2017. And with the manipulator in some of that work, we really didn't see any impacts on either height or yield. And then we also did some work with Modus leading up to, so probably a couple years ahead of registration there. And we did see some significant, not overwhelming, but significant height reductions, but basically very little lodging during that period and no real impacts on yield. So, they were working, but not necessarily putting dollars in your pocket at that point. Since that time, I guess we did roll into, in 2022 was when we first started what SaskBarley initiated. It was called the Enhanced Variety Trials. And the very first phase of that, we kind of had 3 separate sets of trials. One was looking at barley response to more intensive nitrogen fertility or enhanced nitrogen fertility. One was looking at responses to fungicide and kind of the disease packages. And then one, of course, was PGRs, where we did come in with a little bit higher fertility, only really focused on some of the wetter areas of the province and just really looked at some varietal differences in response to PGRs. So I actually don't know if I even have our list here of the varieties that we tested there. Oh, I do. We'll see them later. Yeah, I think I've got them in a couple slides. But 2022, for much of the province, including the areas that we were working with, was another dry year. Some big yields, actually the best yields I've ever seen at Indian Head. We're getting a little bit ahead of ourselves, but still a drier year, not a lot of lodging. And this is kind of what we saw for some of the height reduction. So you can see kind of right across the board, Indian Head, Melfort, Outlook under irrigation, Prince Albert and Scott, where we ran the trials. Every one of those did see a reduction in height. And I should clarify here, we're also working with Modus exclusively in this work. Everything until I get to the latter part, addressing question 2, will be Modus. So some, I would say, small but significant reductions in height with the application of the PGR at all locations. This is averaged across all 6 varieties that we had that year. Very little lodging. We had 2 locations where we did have, I guess, some lodging. Indian Head was one. We were one of the wetter locations. It was actually above normal precipitation, but kind of a funny year. And the lodging was minor, but it was, you could kind of pick out those PGR treatments where it was just a little bit less of a lean or very little, where the stuff that didn't have a PGR wasn't difficult to combine, anything like that. But there was a little bit of lodging. Outlook under irrigation had quite a bit of lodging, that's a scale of 1 to 9. So, that would be noticeable. Maybe not too hard to pick up with the combine, but definitely some significant lodging there. And they virtually eliminated that with the application of the PGR. So again, fairly dry conditions here. This is looking at 2023. I just jump ahead. I'll show you yields in the next slide. So that was a drier year across the board. All of us were quite dry, lower yields. Some locations really didn't even respond with height. There was almost always a trend for height reductions, not always statistically significant, so take it for what you will. But if you look at kind of our first slide there, you can see that, we had, I think, 3 out of the 6 locations where we did this work, or who measured height, I should say, where we saw a significant height reduction. So 50% of the sites. Prince Albert missed that measurement. Flip over to the next one. That's actually looking at lodging there, and all of the sites except Prince Albert didn't see even a hint of lodging. I mean, that was a year, it was just dry. All of our cereals were standing up straight as an arrow. Nice combining. You could travel pretty fast. Prince Albert was kind of a funny one. If we looked at the project as a whole, their measurements were pretty variable. Our experiment was a little bit different here. We had the fungicide treatments, the enhanced fertility, and the PGR with 4 varieties kind of all in one. And there tended to be just a lot of spatial variability, I guess environmental impacts. So statistically, it wasn't significant, but I mean, I think when we isolate those treatments, I can look at that and be pretty confident that we are reducing lodging at Prince Albert under those conditions. It's a shame they didn't get the height, but ultimately lodging is kind of what we're primarily trying to address with these tools. Here's some of our varietal effects, I guess, and this is kind of interesting, and actually I'll show you the next slide, but we see this in both years. So Connect, Synergy, Austinson, Fraser, Claymore, and Oriana were the ones that we were working with, but we did have an interaction there where basically Oriana, we were not reducing height significantly. There was a trend, all of the other ones, it's not dramatic, but it did pop out as significant. This is averaged across all of the different locations, just looking at the varieties. So that was kind of our interaction there, where basically the first 5 varieties we worked with, we did have that significant reduction. Oriana was shorter and, you know, stood up pretty good, I guess, regardless, but we didn't see that impact. Here's 2023. It's a little bit of a busier slide because I really, I guess, wanted to show some of the nuances of all of the treatments that we looked at here. So we have, I'll just maybe go through the treatments very quickly, but those red bars is just kind of our standard package. So not a neglected crop, but it didn't have a fungicide. It had, you know, a more conservative nitrogen rate, no PGR applied, and I think that would be the gist of it. That was kind of, so lower end, no fungicide, no PGR. The green bars are where we gave it that extra nitrogen, so that did tend to get a little bit more height out of that crop, a little more yield potential. The blue ones is what we're interested in here. That's our PGR. And then the fungicide we wouldn't really expect to impact height, but the yellow bars actually don't have a fungicide. Everything else was sprayed with a fungicide because we didn't want disease to be limiting where we were testing the PGRs and the enhanced fertility. But, you know, I guess if we want to distill this, same kind of thing here where we see a similar response on our first 5 varieties that we worked with. But again, Oriana really didn't respond to the PGR or any of the other treatments when it came to plant height. Here's our yield, I guess, both kind of lumped into one slide over the 2-year period. So all in all, you know, I guess I would say, and yield isn't everything when it comes to PGRs. There's other things that have value, but under the conditions that we saw in those years, you know, pretty underwhelming. Most of us didn't have a lot of lodging to begin with. At Prince Albert there, that first year where we did see some lodging, we do see a little bit of a pop for yield. It wasn't quite statistically significant where we wanted to. I think in our report it's flagged as not significant, but when I look at the p-values, it was like 0.7 or something. So that means we're kind of 92% confident that there's something going on there, which I think that's good enough for me in this crowd in general. A lot of times we don't need to be quite that level of rigor, but for the most part, you know, lodging wasn't a limiting factor, and you can see that we weren't gaining any extra yield with those PGRs. That's where I was getting ahead of myself before. I had to do my math multiple times from the combine in Indian Head that year. That's the best barley I've ever grown that year. We were, you know, pushing 140 bushels an acre averaged across the varieties there. 2023, even drier conditions and really no significant yield responses, except for, unusually, was swift current. Very low yield. I mean, it's a borderline crop failure. I can't really explain this. The best thing I can come up with is that maybe with the PGR, a little bit less vegetative growth, a little bit less height, maybe it just hung on to some of that moisture to help with grain filling and gave us a little bit yield in the end. At the end of the day, I mean, if those are your yields, you're not real happy with your crop either way, I guess. But that was the one site that was responsive. Maybe I'm spoiled in Indian Head. And we have more common with you folks up here in Indian Head than they would at Swift Current, but it's a tough site for some cases. So how did that change, I guess, in 2024? I don't have a lot of yield data here just yet, but I will show you some yield with the next project that I think can give us some good insights into what we might expect for this one. But we did carry on with our enhanced variety trials at all sites again in this past year. We changed them up a little bit where we, I guess, dropped it down to, I want to say 4 varieties from 6, and then still had kind of all of the different management practices really looked in there, but just a little bit of a smaller trial in terms of the number of varieties. The other thing that we did is we completely renewed the list of varieties that we were working with. You know, I guess talking with Mitchell, we kind of felt that we had a decent handle, even though every year is a little bit different on kind of how things were performing with the first set of varieties that we worked with. So we just wanted to renew that list. But like Mitchell said, it was a very different year. I'm going to really, for this first kind of set of trials, focus more just on kind of what I saw at Indian Head. But what I can tell you about our site is we started out the year extremely dry. Actually, in April, when I first got out flagging plots, the ground was powder. I was worried about even being able to soil sample and thinking, this is not looking good. But by the time the summer students all came and I wanted to get into the field and keep them busy, it started raining and it wouldn't stop pretty much at that point. So conditions did certainly improve. We had a lot of rain in May. We still got our crops in good time. Cool season. June stayed cool. A lot of rain in June as well. So lots of really lush vegetative growth. Then at that point, I think like many in the province, July came along and things did get really hot. The rain virtually stopped for us at that point. So, we certainly lost some yield potential, but we are in a heavy clay soil. We had all that vegetative growth there, and so still some pretty nice crops. I can comment just on experience. Things were lighter for the most part, just our bushel weights in a lot of the cereals, and yield potential wasn't what we maybe would have expected to see looking at that crop in June and the first 2 weeks of July. I know I was bragging up our crops pretty good at the field day, and then it kind of got a little bit quiet after that, but I still, the way it finished at Indian Head, I certainly wouldn't get on social media and start complaining, because a lot of areas where you're on coarser soils certainly suffered a lot more, and we did okay. But that's just a little bit of a visual of some plots. And Mitchell actually made a trip out to the site he had to walk out to the field, unfortunately, because it just wouldn't stop raining at that point, but just wanted to see some of the treatment effects that we were having there. So I think that might actually be synergy there in probably the absence of any PGR, of course, and possibly some extra fertility. I can't remember for sure which trial that was. But how did that change? So let's just look at some of our results here. So here's really, I'm just going to show you Indian Head, but this is kind of, things will be coming together over the next month or two, and we'll see a little bit more. But this is our height data. So our varieties, I guess, just to back up a little bit, we were working with AAC Prairie, CDC Churchill, one of Aaron's there, I think, was that one that you mentioned? Yeah. Durango, another one, and AB Wrangler. And then that's our overall average. But across the board, not a tremendously, fairly tall crop, I guess, probably pretty close to average, but every one of those did respond in terms of height, and we did see that height reduction with the application of Modus, full rate of Modus there, and no interaction with variety, which is basically telling us that the PGR effect, actually the management effects, this trial was bigger than just PGRs, was consistent across varieties. I'm isolating PGRs here, and actually these p-values will reflect that, because I really just was kind of interested in comparing for this variety with and without PGR. So that gives us a little more strength, I guess, when it comes to saying whether or not that technology had an impact. But we can see that it did for every single one of those. Here's when we look at lodging, and things do get pretty interesting here. Our crop first started going down. It was right at the end of July probably, and honestly I didn't even realize it rained. It didn't rain in town. I got out to the site and the ground was just marginally wet, barely even enough to pick up on your boots, but all of a sudden we pulled up to the Barley and there were just individual kind of treatments here and there that were starting to go down. Check the weather, and sure enough we did have a little storm roll through, which I think we maybe got it was maybe a tenth, something like that, not a lot of rain. But it was bone dry going into that, and it came with some high winds, and so you could hardly even tell that it rained, but just the crops were telling us, and that was kind of when you looked, and it really just kind of carried on from there. That was end of July. Once we got into about, through much of August, as we were just trying to kind of get the combine rolling, it seemed like we were getting thunderstorms every night at that point, and 70, 80K winds. We had some days where winds were up over 100, and it just wouldn't stop raining. I did have challenges getting out some of these crops that did go down a little bit more. I just couldn't get the darn things combined. Lentils, for example, were flat and the ground was just too wet to get them. Barley, I kind of struggled the same way because some of that was going down, that the undergrowth just wasn't drying out, and it was really hard to pick up. I actually combined flax, interesting side note, before either lentils or barley this past year, which that's a first. But coming back to our lodging, I guess we can see that a couple here really stood out kind of right out of the gate. Prairie and Durango really hadn't lodged at all, and the PGR didn't have any impact there. I think in our seed guide, I do have some notes here, but I think actually Churchill might be better than Prairie, I think, in the seed guide for lodging, but we did see that that didn't quite materialize at Indian Head, and I think that's just kind of normal variation that we can sometimes see the way things hit the stages that they're at. But for both Wrangler and Churchill, we did have significantly more lodging. pretty much eliminated again with the PGR. So they really work quite well. There was something else I thought I wanted to say about that. Yes. So these ratings were done probably close to 2 weeks before I combined, and things would have progressed a little bit farther between there and combining. In a perfect world, I maybe would have gone out and actually just rated everything again, but we were trying to, progress with harvest like everyone else and didn't get to that. But I think the patterns would have been pretty consistent. And this was, already a basically good 2 weeks of some pretty significant weather and lots of pressure for lodging. But we do see management affecting lodging, PGR affecting lodging, and that significant interaction. What was really interesting to me this year was just how much negative impact with respect to lodging in particular that extra nitrogen could have. So it really kind of, I think encouraged us to maybe dial in those N rates a little bit closer. We've gotten away with some pretty high rates, I don't think, with yield potential, but moisture coming at the right time. We haven't been getting the lodging. We've had still good yields for the most part, so protein hasn't necessarily been a big issue, and we've maybe been creeping up with our N fertility. But where we gave an extra 30 pounds of nitrogen here, it really made a difference when it came to how that crop stood up. So just a note on fertility here, we were adjusting for soil nitrogen, and our standard rate was soil nitrogen plus fertilizer was 120 pounds, so still a pretty good rate. And then we tacked on another 30 pounds for that enhanced N fertility. But that just goes to show, so this is our control, no PGR. Same thing, no PGR, but just that extra 30 pounds of nitrogen, how much more lodging that caused. So that was interesting. I know I'm here to talk about PGRs, but I do think that's relevant to the topic for sure. And this is just kind of taking a step back and looking at all those treatments together. So you can see our red bars are our standard management. Blue is the fertility. Green is kind of standard management. So it's not getting a PGR. It is getting a fungicide, but it's getting that extra 30 pounds of nitrogen. And really kind of jumped out at us. And Churchill and Wrangler were, of the bunch, kind of the worst there, where Durango and Prairie, for the most part, stood up quite well throughout it. Actually, no statistically significant differences across our management treatments for those varieties. So, I don't know how I'm doing for time. Am I going too slow, too fast, just right? I've got a little bit to get through here. I'm not even looking at my clock, but I tend to be long-winded and always have too much data for the amount of time I'm allotted, but we'll do our best. You guys can tell me to hurry up if I need to, but how did the treatments look on our new PGR mixing project at Indian Head in particular, and can I comment on some other sites? So we'll go into that. This was a really, to me, quite an exciting project, and we had a good year for it as well, which was, we kind of lucked out there because, you never really know what you're going to get when you come up with these protocols 5 months ahead of planting time and then 3 months of growing season. But really we wanted to look at the responses of three, either currently adopted or up and coming malting varieties to some of the PGR options that are available. So either manipulator, chlormaclock chloride, it'll be abbreviated as CC, or Modus. Oh, I've got and there. I'll have to correct that there for my presentation next week. Modus, which is trinexapac ethyl, so abbreviated as TE. Applied both alone, or what was unique here is we also looked at them in combination. So in combination, I'll just show you my treatments. I think that's the easiest. So our locations, we did try to focus on some of the wetter ones: Indian Head, Prince Albert, Scott, and Outlook. And then our treatments, we had 7 different PGR treatments. So of course we've got our untreated control here. And then if we, flip back up to the top, we've got a full rate of Modus. Misspelled, I see. Lots of little errors I'm finding. Full rate of manipulator. Half rate each of Modus and manipulator. So not really one that we're, specifically thinking that people would be using, but we just kind of wanted to balance out our treatments. And then we get into our tank mixes. So we either took, this is probably the most practical of the bunch, where we just take a half rate of each of those 2 active ingredients and apply it both in the same sprayer tank at the same time, of course. And then here's where we really get wild and basically take a full rate of each product, throw it into the sprayer, and apply those together. Something that probably gets a little bit expensive. I think we're up over $30 an acre plus your application costs. Pretty potential to be pretty hot, so not something I would, for the faint of heart, or that I would really recommend, but it's interesting. Our varieties were Synergy, which I think is probably the #1 variety here right now, and then some up-and-comers here, Fraser and Connect. And I don't have too much, I don't think, experience with Fraser prior to this year here, but have been growing Connect in some other trials for quite a few years. Data collection, emergence, just to kind of get a handle. We just did our control. We did phyto ratings. We thought this was important. I don't present it because we didn't actually see a lot of phyto. I do have that. It will be in the reports, don't worry, but I don't bring it up today. But honestly, there was really nothing to be concerned about anyways. I know when I rated our plots at Indian Head, I could see just some very minor, just spots, like almost like a little bit of surfactant burn, but it was so minor. I think on a scale of 1 to 5, I had a few plots that might have been hitting 0.5. It wasn't anything to be concerned about. When I did apply our treatments at Indian Head was kind of interesting conditions. I got mixed up one day, ready to go. It was raining all the time. This was in June. And the wind got up, so we couldn't spray. So I talked to actually some of the reps, said, can I leave these chemicals in my bottles, mixed up, ready to go, get out either tonight or tomorrow morning? And actually it was the fellow from Belgium I talked to said, if you apply that to wet plants, that you might see more burn. So I thought, well, I'll do what I can, but we're rating things anyways, so we'll just go for it. It started drizzling that night. The wind eventually went down, but then it was spitting that night. And so we got out there at 5:30 the next morning, and were some very wet plants, but it was progressively getting drier. And that's when we put on our treatments, because the wind was supposed to get wild that day again too, and we had to do this. But so that was just kind of the condition. So probably pretty good conditions to maybe see some phyto. Plant height, of course, we're going to do. Lodging, that's a no-brainer. Yield, and then some quality measurements. And we did all of our quality in-house and are basically looking at test weight, TKW, percent plumps, and protein. So I will start with Indian Head here. I do have data from Scott as well that I'm going to show you. So here's plant height. Again, I don't show the phyto, but even under those conditions, there was really nothing to be concerned about visually anyways that we could see. We'll look at the quality that we have anyways, and that might tell a different story, but in terms of leaf spotting, not a lot. Here is our overall, I guess, averaged across varieties effects on plant height here. So here's our control, is the orange bars here. That's our tallest. And right off the bat, I guess the only thing that didn't reduce height was that half rate of manipulator. That didn't, it kind of trended down a little bit, but not statistically, and you'd really never see it. Full rate of Modus worked pretty good. Full rate of manipulator actually worked pretty good for height, and not quite as good as Modus, but they're in the same ballpark. Our tank mix here of the half rate of each was numerically a little bit better than Modus, but basically the same thing when we take a little bit of variability into account. This 1X tank mix, anyone who was at our field day, that really jumped out at you, and we could see those ones from a mile away. Those were noticeably shorter, and it really shortened up those plants. So that's looking at our height. If we just kind of look at the stats here, not to get too bogged down, variety by PGR interactions were not significant, which is telling us that basically that response was pretty consistent across the varieties that we were working with. So here's looking at lodging. As we know, we had a lot of lodging. Synergy stood out, not stood up so much, and not necessarily in a good way. Nice variety, but it was the one that went down on us by far more than any of the others. Both Fraser and Connect were pretty comparable to one another. When we look at our PGR treatments, over here is our untreated control. On a scale of 1 to 9 we're looking at there, I was coming in at basically, this is averaged across varieties, like 4.5. So, if I isolated Synergy there, it was probably more up. Like I had some plots that was rating like 7 or 8 out of 9. They were pretty much flat, like some of the pictures that we saw there. I guess our half rate of manipulator didn't help at all. Our full rate of manipulator, numerically a little bit better, so maybe a little bit of improvement, but certainly not across all plots, not statistically significant. So that didn't work as well as we would have liked. Full rate of Modus, that was a winner right there. That worked pretty well for us. So, that alone is about as good as we're going to get. Half rate of Modus, not statistically different, numerically a little bit. We'll see if maybe anything comes out of that as we get more data, a little bit more experience under our belt. But even that seemed to actually help quite a bit with the lodging. And our tank mixes, not significantly different. None of these were significantly different, but even just kind of talking to Mitchell, it really looked like that 1X mix was almost bulletproof there, that thing couldn't go down. Variety by PGR effects on lodging. So yeah, we do have a significant interaction here. To me, the interaction isn't all that interesting because for the most part, our patterns are quite similar across the board. I think it's really just coming from some of these varieties that we didn't have that same level of lodging pressure. Both Fraser and Connect, maybe Connect to a little greater extent than Fraser. It didn't necessarily matter even without the PGRs. We didn't have a lot of lodging, but the patterns were really quite similar across the board. But just everything was really jumped out, more separation with synergy. So that's kind of where that interaction's coming from. Here's our grain yield results. So prior to this year, things have been pretty underwhelming with respect to grain yield and PGRs on barley. This still isn't anything so dramatic, but it's certainly significant and nothing to, shrug off, I guess. I think we're at about a 10% yield advantage to that full rate of Modus over our untreated control, which is, definitely more than enough to pay for that cost of application. We've got a few others that don't differ from that. Our half rate of Trinexapac still yielded quite well, not quite where we wanted to be or where we were with the full rate. That half rate tank mix looked pretty good. Everything else was a B. So manipulator, full or half rate didn't differ from the control for yields. That 1X tank mix, even though you couldn't knock that crop down, it I think was just starting to have some negative impact. It's just something we can see with PGRs, not often. These are pretty safe, but it's not unheard of. Test weight, this is just hot off the press, but we do, for the most part, not see a heck of a lot there. None of them actually significantly differed from the control, but with that full rate of Trinexapac, we actually do have the highest test weight of the bunch. And I suspect that's probably that it was quite safe under the conditions encounter and then also didn't lodge. So even that early lodging in July might have had some negative impact on test weight, I'm thinking. Probably where that comes from. We do have an interaction, and I haven't really had a lot of time to kind of digest this. I really just got it, but for the most part, our patterns are similar. I might have had some notes here. Maybe just that Connect was less sensitive to manipulator and perhaps more sensitive to the tank mixes is what we're seeing here. That's, I suppose, one thing that does jump out. Even that half rate tank mix, we are losing some test weight with that tank mix, where everything else is pretty much the same as the control. So not a lot for downside. We do see some where maybe looks like that manipulator could have had some negative impact on test weight. Generally not significantly different from the control, but that 1X rate of Modus is kind of consistently up amongst the top and not causing us any harm, which is good news under the conditions where we're really supposed to be using these products and seeing some benefits. Protein, nothing. A little bit of varietal differences there, but none of the products affected protein. The only thing I really ever worry about with protein, for the most part with PGRs in barley, if you're in an environment that needs a PGR, I wouldn't be worried about it at all, because with malt, we do want that lower protein. What we'll sometimes see with PGRs is if we get a big yield bump, we can lose a little bit of protein. So that's kind of something that people have always wanted to manage with wheat. Barley, I would see it as a positive, particularly with malt, if it is going to happen. Where I would have been most concerned, and we see some tendencies, is maybe where we were potentially having some negative impact on yield. You might see protein jump a little bit, but can't say we really saw that at Indian Head. Now let's move on to Scott. So a little bit of a different environment. They just didn't have the lodging, basically. I think it was still a pretty good production year for the most part at Scott. Pretty similar weather patterns to what we had at Indian Head, but they just didn't maybe have quite as much vegetative growth early on and maybe didn't catch some of the rains. Our problem at Indian Head was twofold. Number one, in May and June, we had all that rain, cool conditions, just so much vegetative growth there, which in itself was maybe, setting us up for that risk of lodging. But what really did it was the wind and the rain that we got in August and the very end of July. It just, if we didn't get some of that weather, it probably would have stood quite well. But it just, really took a pounding kind of that first couple of weeks of August when it was raining every night. Height responses, for the most part, they're quite similar to Indian Head, with the exception of they really didn't even see any height reduction with manipulator. So it just wasn't working as well at Scott. Their 1X rate of Modus were quite good. Not quite as good with the half rate. Still better than manipulator, whether a full rate or half. Tank mixes, looked good. That 1x rate was again standing out as the shortest of the bunch, and that half rate pretty similar, just a full rate of Motus, not necessarily any better. Actually a little bit worse, but statistically the same. Variety by PGR tells us that no interaction there, tells us that the PGR effect on height at Scott was consistent across varieties. Looking at lodging, they had a little bit, they had some treatment effects. Certainly not the extent of lodging that we saw at Indian Head though. So, here on the scale of 9, we don't have anything that hits a 2. And I'm calling a 2 usually, is just kind of that crop that, yeah, it's got a good lean. Maybe you can't look right down between individual rows, right? But it's not causing you any trouble with harvesting. It's standing pretty well overall. So they do have some differences there. Again, that full rate of Motus is doing the job. No real advantage to the mixes over that full rate of Motus, and they're not getting really that great a protection against lodging with the manipulator. Barley yields, really nothing was better than the control. Numerically, their control was the best. For the most part, we didn't see a lot of harm with the PGRs, which I think is a win overall. And I have had farmers tell me that, even if I don't get a yield gain, if I can maybe combine that crop earlier or move the machines through the field quicker, that's still, it's maybe not perfect, but it's still got some value and going to make me at least consider a PGR. They didn't have a lot of lodging. I wouldn't be concerned about it. And for the most part, we see a whole lot of A's there. The only exception is our full rate tank mix, where we got that full rate of each product, is actually causing some significant yield reduction there, which just brings us back to that maybe being a little bit too hot, especially if you're under, some potentially more drought risk kind of environments. If you've got all the moisture in the world, probably not going to hurt you, but it's getting riskier. Barley test weight, no significant differences there. We see a little bit of up and down where maybe, some treatments are having some negative impacts, but variability was pretty high at this site with their test weights for some reason as well too. So none of that actually popped out as being significant. Seed weights, I've got all the quality data from Scott. No impacts. We've got some variety differences, which isn't really what we're here for, but the PGRs weren't having any impact on seed weight. This is what they did impact though, and that was our percent plump kernels. So I think that's interesting, something to take note of, but really the only one that was hurting us to a significant extent was where we went in with that full rate of both products. We do see maybe some very small drops there, but nothing statistically significant, so we can't necessarily say that that's specifically due to the treatments, and really not with the level of variability we saw, no real evidence that that's the case. But with our full rate tank mix, we certainly do. Barley protein, even though we saw some yield loss, I guess, with the one site, that full rate tank mix numerically hits the highest, but it didn't really get us into any trouble relative to any of the other treatments when it came to protein. And I think that is all I have for data. So I'm not sure if I used up more time than I was supposed to, but hopefully we, if there's any kind of questions or, people can always feel free to reach out to me as well. My contact info is there, but anybody use some PGRs this year? Anybody struggle with lodging in their cereals this year? Yeah, it seemed to certainly be a hot topic. I did the coffee shop talks for Sask Wheat there earlier in December, and that's what they specifically wanted me to come talk about. I was up north of Saskatoon for that, and we'll be kind of giving a broader discussion, I guess, on PGRs on cereals next week at the agronomy research update too. So it's been something that we've, I think really fought with kind of when I go back to when we first got PGRs. Just to take you on a little bit of a history, I guess, of my experience with it. 2012 is when we first got it, and that was when, at the time, Engage Agro first got a hold of chlormecoque chloride in the current formulation that is manipulator, and we were doing some other work for them. We were actually spraying pod sealants on wheat to reduce pre-harvest sprouting. So I don't know if that's something that didn't work, but we didn't really have the conditions for it. But they got this other product that they were kind of excited about, and they were like, "Can you use this?" And I was like, "Well, we don't work for free. You got to pay us. But if you if you want, you can give me a little bottle, and I can just spray half of your trial that we've already got in place there." So that's what I did, and that was 2012. We had Unity wheat, really bad year for disease, lodging, all that, and it really set the bar high. Like I think we had about a 15 or a 20 centimeter reduction in height on that wheat, and our yields were like 50% higher. It was wild. We lost 1.5 percentage points. But then from that point, we did a lot of work, really just trying to dial in that label with Engage Agro at the time, now Belcham. And so we were looking at timings of application, different rates of application, variety profiling, all that. And then it's just kind of more recently, like Mitchell said, where we move things into barley and to a lesser extent oats. We're doing a little bit of work with oats as well. I would say oats, if you're oat growers, which you probably are up here, will behave pretty similar to barley for the most part, where Motus tends to be the stronger active ingredient, and maybe not as responsive as wheat under most circumstances. Haven't seen some of the negatives. I do have an interesting story with oats, though. I think it was 2018. We had Arborg oats, pretty dry year, and we had a trial similar to what we just did here with all those different tank mixes. And when I took Arborg oats in a dry year and hit them with a full rate of both manipulator and Motus, the plants were shorter than the canola stubble I direct seeded them into, and it was crazy. I was 3/4 of the way through a plot before I had enough material for the reel to scoop it up and bring it into the combine, and we did see some negative impact on yield and quality there as well too. And then the last few years, just with things being drier, lodging being less of an issue, I really do think we got to give some credit to the breeders. Our varieties have gotten better, and we do see, sometimes still these yield pops in the absence of lodging or with relatively light lodging, but they're not as consistent. They tend to be smaller in magnitude, and you certainly don't have the harvest inefficiencies that we can with a crop that really grows down. So I think as I won't rule out that you couldn't see a benefit to a PGR in a really good variety that's probably not going to lodge, but the likelihood and the magnitude of that benefit are more than likely going to be less. So we're pretty tight on growth stage in terms of our application, and yeah, everything was pretty close. We were targeting 30 to 32 here, so really just kind of pseudo stem elongation, and no, none of the varieties stood out as kind of maybe being identified as needing a separate application date. Is that kind of what you mean, or yeah. To maybe explain some differences across varieties, things like that. Yeah. The question is do we see maybe more of a consistent yield bump with wheat than with barley? I would say anecdotally, yes. Unfortunately, I can't really separate crop type from some of the environmental conditions that we've had. So a lot of my experience with wheat, 2012 through 17, 18, 17 things were tapering off, but we were getting some really good responses, but that was just through a wet cycle where we had a lot of lodging, maybe older varieties. We are doing some work with variety profiling and Motus versus manipulator with wheat here right now too, and I can't say that we're seeing a tremendous amount of benefit. This year here, we had more lodging. I do have some significant yield benefits just this past year at Indian Head. I wouldn't say better than what we got with barley. If anything, maybe not quite as strong. It's a little bit, some nuances there with our plot layout, split plot versus randomized kind of design. So I don't know if I have the statistical strength to pick them up, but hard to say. One thing I will say with wheat is that anecdotally, to a large extent, because we just haven't had the pressure, I would say we probably see more consistent responses to manipulator as opposed to Motus with wheat. So that's just kind of where my gut would, and if it was me paying the bills and growing the crops, I would probably lean that direction for a product. Where barley and oats, it's the other way, where I probably would really choose Motus as my product of choice. But no, these last couple of years with wheat have been pretty Motus, or pretty pretty modest, I guess, what we've been seeing for responses there. Last year, under quite dry conditions, but still good yields. I think I had wheat kind of hovering in that 70 to 80 bushel an acre. I was about I think on average a 6 or 7% yield benefit with manipulator in particular on wheat. Not quite there with the Motus. And so it definitely paid for the cost of application. It actually made us a little bit of money, but not like some of the results we've seen in previous years. And in some of those years with barley at our site, we really didn't see much benefit. So maybe, I guess, if in that respect, yeah, maybe sometimes a little bit better than wheat, but this year I wouldn't really say that. I'll have to look at a little bit closer at the wheat data, but I think it was probably pretty comparable to what we saw with the barley here. This year we certainly had worse lodging with the barley. than we did with any of the wheat varieties we were growing. And it wasn't all varieties, but the ones that went down, especially when we had that extra nitrogen, it would have almost been nice. But of course, funds are finite. But to pair it up with that higher fertility. And I should mention that in this latter trial here, where we do the PGR mixing, we really threw the nitrogen to it there. I think I was with soil land, which I only had about 11 or 12 pounds. I think we were like 175 pounds or something. So we really threw the nitrogen at it there to induce some lodging. So, maybe a lot of farmers wouldn't have had quite that dramatic of lodging that what we saw. And it's also why our protein was, I think we were like averaging about 15% there. I questioned our tech when I first started. Our one replicate was a little bit lower yielding. When I first just kind of pulled up the data sheet after he sent it to me, my proteins were up in 16%, and I called him up and I said, "You're using the wrong calibration on the NIR. There's no way our protein's that high." But then I kind of looked, and where we had the higher yields, it did come down to still not where you'd want it to be for malting. And no, he did. He certainly was using the right curve. And then I looked back at my notes and like, oh yeah, we also gave it 160 pounds of nitrogen. So, yeah, is marketability going to be any better or worse with PGRs? And I think it's certainly something you need to be careful of. Mitchell might be better to comment on this, but my understanding, I think, is that manipulator in particular is flagged as a kind of on the keep it clean list for malting barley. With oats, I don't think you really want to check with whoever you're selling the grain to. I think a lot of the milling companies are probably going to be pretty apprehensive there. So if it's feed, no problem. The good news is that I don't think there's any such restrictions with Modus for either malt or feed, and that is the product that, without hesitation, I would recommend as well on your barley. So it never hurts to ask, whoever you're selling your grain to. I think it's something you want to keep up with before you go out and make that application. The other good thing about PGRs too, even with some fungicides, and Kelly certainly knows this, like sometimes it's really hard to know what your risk of is going to be at the time when you have to make that decision to do an application. Where with PGRs, I think it's a little bit easier anyways. If you've got that lush growth, like we're on 12-inch spacing, if it's June 10th and I can't see in between rows and there's lots of soil moisture, I know that there's pretty good potential for lodging to be an issue. It's not a guarantee, but so it's something that you can, I think, make a fairly educated decision on when the time comes to put it on, which is nice. We don't always have that luxury with our inputs where it's kind of more insurance, but here it's still insurance. It's crop protection, not necessarily yield building. But I do think that if you go out there and you just, you don't have that lush crop, your rows aren't necessarily filling in that thick, it's dry, there's no rain in the forecast, for the most part, you can probably save your money. Not to say that you might not see a small yield benefit, but some years, which we never had the trials in place, so I can't really comment, but I think when Manipulator first hit the market, like 2021, would have been when it was kind of first, 2020? Yeah, when that was kind of first widely available, a lot of guys gave it a try, probably didn't need it, but they were excited to have this new product in the shed. And it caused some problems. Yeah, we're just, heads weren't coming out of the boot and causing some yield loss. So, which was a bit of a tough launch, I guess, coming out of some wet years. But hopefully that turns around and we get into a cycle where we see some rains on a regular basis. In your opinion, where is the best barley growing area in Saskatchewan? I don't know. Right here. No, I honestly don't know. I'm biased. I find at Indian Head, we are pretty consistent. It's well-drained land, but nice heavy soil. Usually not too wet, not too dry. No salinity, things like that. But I don't know. That's a tough question for me to ask. Anywhere I think where you kind of can have that consistent yield potential, and it's a little bit easier to keep your protein levels down, things like that. And, maybe Aaron might have a better sense of that too, even with some of the co-op trials there. And I work with primarily. Not too much out of the province. We will venture out a little bit, get into Manitoba, Brandon, or Western Manitoba in particular, and not too much in Alberta. But you get into central Alberta, of course. Anywhere in the black soil zone, I think, right? Dark brown, black. I don't know. That's a loaded question. I don't know if I really know the answer. I feel pretty blessed to do the work that I do at Indian Head. I know it is an area where even in the dry years, it's very rare to have a crop failure. Just a few timely rains and bit of a recharge over the winter can carry us a long ways. And just even our land with the good surface drainage, for the most part, we can flag our plots from corner to corner in a field without worrying about sloughs, salinity, things like that. So, but time to move on.
Thanks.
Okay.
Thanks very much, Chris. Our final topic for the night is focused on more yield robbers, this time on plant disease. So farming in a highly productive area like Northeast Saskatchewan, it obviously presents some additional challenges. And so managing barley for the demanding specifications in the malt industry are an added challenge to that as well. So Dr. Kelly Turkington has focused his career on field pathology and has provided the industry with his research results for 30 years?
Well, I've been at Lacombe since 94.
Yeah,
so,
94. So barley has been an integral part of Kelly's research program, also working on wheat and dabbling into canola at various points as well. So Kelly's got a lot of experience from the industry side of things, and his role has been integral in terms of disease management, as well as doing some of the variety evaluations that Aaron alluded to in his presentation. And so Kelly sees a lot of different barley varieties and different practices throughout the industry, and is going to provide some insight on that. So Kelly's coming here from Lacombe at the Ag Canada station there. And I was on a panel last week and had a similar type of question as to what I'm going to ask Kelly. I'm not sure how it made you feel when I posed the question, but it's like it almost makes you feel a little bit old when you ask any kind of a reference to a long time in the industry. So, well, take it as a sign of respect, not a jab. So, in the fourth quarter of your career, you've seen a lot of change in the industry. What's the most critical research you've done that is yet to be adopted by the industry? And question 2, and I'll let you roll with it, Kelly. FHB, Fusarium Head Blight risk, is a difficult beast to manage. 2024 was the first year with a barley-specific FHB risk map available for producers. How should producers incorporate risk maps into their fungicide management strategies, especially when that risk may appear differently for different crop types? Kelly.
Well, thank you, Mitchell. It's a pleasure to be here. Coming to speak to producers at events like this, industry events, actually is probably one of the things that I like most about my job. Some of the other admin stuff I don't like as much, so this is always a great opportunity for me to come and speak to you. So at Lacombe, we're part of a great group. I work as part of an integrated crop management team with Brianne Tideman, our wheat scientist, and Hiroshi Kubota is our agronomist. We've got some great technical staff, great collaborators across the Prairie region with Ag Canada, with universities, with producer groups, with the Applied Research Associations, and so on. We've had some great interaction with producers, producer group representatives, and industry. So I value those interactions very much over the course of my career. We've also been very fortunate to have funding from a number of different producer groups over a number of years. So if we look at the first question, which is in the fourth quarter of your career. Now, my dad farmed around St. Brew. He was actually at Dalesford. We were about 9 miles south of St. Brew. He got out of farming in '98. So lots of fond memories of Melfort. Getting up into this area occasionally and being at the farm in St. Brew. Did a lot of my graduate work on canola and sclerotinia forecasting using petal testing with Robin Morrell. We did a lot of work at the Melfort Research Center starting in about '83 through to about '91 or so. So what's the most critical research that you've done that's yet to be adopted by industry? And quite frankly, it was a bit of a tough question. Our research program and the collaboration that I've had, we work very closely with the barley breeders across the Prairie region, including Aaron and colleagues in Brandon and Lacombe. So the varieties that come out that have improved disease resistance packages are adopted quite readily by producers. A lot of the work we do is field-based, so a lot of the concepts and technologies that we've developed or refined find themselves onto the farm quite readily. So I'm very thankful for that. So certainly research is important, but over the years I've been mentored by producers, by industry staff, by fellow researchers, by my supervisor, Robin Morrell. And it's really some of the things that I've seen gaps in has been in the knowledge and understanding of disease issues and how to use that information to better manage plant disease risk. So the one thing that I can't emphasize enough is the importance of knowing and understanding the enemies that you're facing on your farm on a field-to-field basis. That can't be overstated. The importance of timely and accurate disease diagnosis is so important. And I've made issues over the years, or had issues, I've seen issues, whether it's producers, whether it's crop consultants, whether it's fellow researchers, and so on. Now, learning and developing that sense of being able to identify issues is going to take time. It takes several years because there are often nuances when you look at all the factors that impact that crop during the growing season, both abiotic factors like temperature stress, drought stress, hail, etc., or biotic factors like insects, insect damage, disease development, and so on. I can't also understate or overstate the importance of getting out into the field, and that's one part of the job that I enjoy the most. Each summer I try to get off the research farm, out of that bubble, quite frankly, and into producer fields. I do a lot of interaction with crop consultants in our area, with some of the malting companies. I go out a lot with the RAR agronomists, RAR Malting, based out of Alex. So getting out into the field, looking at what's happening, getting that sense of factors in the field, and then also the extension that occurs through producer groups like SaskBarley is so valuable, and sometimes we don't recognize the importance of that. One area that we've worked on since the late 90s is fungicide application, and especially in barley and especially for leaf disease management. And there are a few things there that I want to pass on, some observations that we've made, research results, and so on. It's an effective tool, quite frankly, but when the risk of disease is sufficient. And if you're growing a variety that has a moderately resistant or a resistant rating in the variety guide, especially to the leaf spot complex, so things like net blotch, scald, spot blotch, and so on, and rust resistance especially, that genetics that the breeder has incorporated with the assistance of the pathologist is doing your heavy lifting in terms of managing disease. And often you don't need to spray a fungicide when you have that resistance package present, and especially with the rust. The challenge, and certainly Aaron would concur, is packaging resistance to all the disease issues that you face. Fusarium, stem rust, surface-borne smut, loose smut, scald, 2 types of net blotch, spot blotch, and so on. Pulling in moderate to high levels of resistance to all of those diseases at the same time in terms of selecting for high yield, selecting for the malting quality can be quite challenging. The other thing is that when you have dry conditions and or a lack of inoculum, those are conditions where you don't really need to put in that spray and incur that input cost. Timing can have a huge impact. And we started looking at timing in the late 90s, comparing herbicide, flag, and actually at that time, head emergence timing. So you can go in too late and the disease is already established on the key plant tissues that contribute to grain filling and yield. And in barley, that's the penultimate leaf, not necessarily the flag leaf, because often many of the varieties, the flag leaf is quite small and is not a big contributor to yield. It's the penultimate leaf, so the second leaf from the head and the third leaf down. So if you get a lot of disease developing on that, by the time you get your fungicide on, you're not necessarily getting the benefit to the extent that you want out of that fungicide application. You can go in and spray too early, and you don't even touch the key leaf tissues. And this graphic here is just an illustration. It was some work that we did at Lacombe. We had the same trial at Melfort, Indian Head, Scott, a couple of locations in Alberta, and then Brandon. And where we put on a herbicide timing, we really don't see a huge benefit associated to that particular practice. So you go in and spray at that time, you have an impact on the healthy leaf tissue that's there, but then the disease continues to develop. And later on, when those upper canopy leaves come out, they're totally unprotected. The other thing to keep in mind is that fungicides are often only effective for 2 to 3 weeks at best. So you're wanting to maintain a concentration, a critical concentration of fungicide active within that plant tissue in order to manage the risk from those particular leaf diseases. Is your target actually a fungal disease? And I've had many examples of this over the last 30 years where I get calls or I go out to fields and the issues that are there are not disease related. They in fact could be due to drought stress and heat stress in the crop. In many cases, I've had calls where a producer would say, I've sprayed, and where I've sprayed, the disease is worse, which is a bit of a head scratcher. So I ask a lot of questions when I'm trying to diagnose issues like that. And often I'll say, did you put anything else into the mixture? And invariably, the one that was most common is some of the older generation of foliar copper products, which have a lot of phytotoxicity issues and cause some damage. So in those cases, the fungicide was doing its part. It was the fact that they had that added copper, which was a bit hot on that plant. And last but not least is that fungicide application doesn't mean a disease-free crop. And often producers might have experiences with weeds or insects where they spray, the weeds are all dead, they can see them dead, the insects are dead. That's not the same case. So I can't emphasize the importance of leaving unsprayed areas in your crop in order to look at assessing the performance of that particular input. So one of the other questions I get a lot about, and I'll touch on this a little later in terms of assessing risk in relation to Fusarium Head Blight. When should I go in? Should I use a herbicide timing? And the research that we've done, some of the other research that's been done in wheat, really points to that the herbicide timing is not the best target to use or to hit within your cereal crop. Invariably, if you have an emerging issue and you spray at the herbicide timing, you're going to have to come back in again at flag leaf emergence or head emergence to spray that crop. And every time you spray with a fungicide, that's a selection event on that fungal pathogen population to adapt to that particular fungicide active. We're nowhere near Europe. We're nowhere near Australia in terms of their issues with fungicide resistance in cereals, but there are some concerns. I'll just wait a few seconds. There we go. So the question is, should I go in at flag only? Should I go in at heading only? Or should I go in at both the flag leaf emergence and heading? And I'll touch on that a little later on. So the second question was, FHB risk is difficult to manage. And I often use northeastern Saskatchewan when I talk to producers in Alberta and elsewhere in terms of the challenges associated with FHB management. The concept of integrated management for Fusarium Head Blight typically has come out of North Dakota and colleagues like Marshall McMullen, who's now retired at North Dakota State University. So producers in this area for the last 15 years or more have been following what, in quotation marks, the experts are recommending. Rotation, don't plant barley on barley or wheat on wheat. Use a resistant variety, spray a fungicide. They do all three of those practices, and they're still getting hammered in terms of grade reduction due to FDKs for wheat and rejection in terms of malting status, in terms of DON contamination or deoxynivalenol. So 2024 was the first year that we saw the introduction of a prairie-wide Fusarium Head Blight risk map tool, and there were some challenges associated with that in terms of some variation between wheat maps and barley maps, and how do we address that? So what I'm going to do is just talk a bit about the background. So the maps that we see, whether it's in Western Canada, whether it's in the US, where they have the SCAB forecasting system. In the US, they refer to Fusarium Head Blight as SCAB. Typically, what they do is they look at output from forecasting models that look at parameters such as rainfall, temperature, relative humidity, and then those parameters are used. They use statistics to predict the potential risk or the probability of a particular level of disease occurring. And in the most cases, it's at least 10% Fusarium Head Blight severity on that cereal head. So in Saskatchewan, you had with the Sask Wheat Commission, they worked with a private company. They looked at temperature and or relative humidity in the previous 5 days, plus a 2-day forecast. The reason why I have a question mark there is that it's a private company. They were fairly cautious about releasing the nature of their forecasting system, but likely it was based on a combination of temperature and relative humidity. In Manitoba, for quite a while now, and then in 2017, I worked with people like Mike Harding with Alberta Ag, Brian Kennedy with Alberta Wheat at that time, and we introduced Alberta producers to the risk maps. And we used the forecasting system out of Manitoba, which looked at hours of precipitation and the hours with temperatures between 10 or 15 degrees C and 30 during the previous 7 days. And this was one of the first iterations of the US forecasting model developed by Eric DeWolf at Kansas State, along with Pierce Paul at Ohio State and Pierce Paul's predecessor, whose name escapes me right now. So if we look at the maps at that time, each province had their own categorization based on slightly different threshold values. So low, moderate, high, and extreme risk were the categories. If you look at the US, they looked at initially the number of hours when the temperature was between 9 and 30, so a fairly wide range of temperatures, and where the RH was above 90% over the previous 7 days. The current models, they've gone to strictly looking at mean relative humidity over a 14-day period prior to flowering. And in the newer system, you can then add in as a producer weather forecasts for the next 2, 4, or 6 days. So that's the current system. So in 2022, as a result of work by a master's student at the U of M and a project that Paul Bullock led at the University of Manitoba, and it was across the Prairie region, they looked at developing the relationships between particular parameters for individual crop types, so barley, spring wheat, durum, winter wheat, and so on. So the risk maps are calculated and the risk from May 15th through August 31st, and they don't forecast beyond the current date, so they don't look at incorporating forecast weather conditions. They look at the previous 2-week period and weather parameters to calculate a risk level, and they've used an index value or severity value of 5% versus 10% in some of the previous models developed, especially out of the US. So what I did was I went in and I queried the system. So we looked at July 12th, 2024, spring wheat, AAC Brandon. I went in and looked at the same date, but with barley and with AAC Connect. Both of those wheat and barley varieties have a moderately resistant rating for Fusarium Head Blight. Now, if we look at the maps, so I focused in more on eastern Saskatchewan. Here's for AAC Brandon, a moderately risk. You can see that we've got large areas around Yorkton and north, east, west, that are in that very high to high range. If we look at the map for AAC Connect, a bit of a different story. So my understanding, talking with Mitchell over the course of the summer, a lot of confusion and concern related to why are we seeing the differences? And we're going to talk a bit about that in a few moments. So if we zoom in, you can see outside of the Regina area, we were transitioning from moderate to high risk. And in Regina, we were low risk for more distance outside of Regina, and the low risk, eventually getting into moderate and then to high, but nothing in the very high range. So that's caused a lot of concern and questions from producers in terms of how to interpret the results. So the current system for spring wheat is based on mean daily maximum RH and the number of hours when the temperature was between 25 and 28 degrees C. So fairly high temperature conditions for the previous 14-day period. For barley, the model is based on mean daily rainfall. And initially, the US system relied on rainfall, and they focused mostly on winter wheat and spring wheat. But they've moved away from rainfall and have now focused more on relative humidity. So that may be one reason you see the difference between the two results. So how do you rectify that? How do you, if you're a barley producer and you're also got wheat, how do you deal with perhaps potentially different risk ratings on your individual farm? I think it's important to go back and look at the disease cycle of Fusarium head blight and what we're actually trying to predict and the factors that we're looking at in terms of temperature and moisture. So Fusarium is a residue-borne fungus. Whether it's in small grain cereals like wheat and barley or corn, it survives on old crop residues. On those residues, you have the production of the sexual fruiting structures, the perithecia, and that's illustrated here, which produce spores. In the past, in Alberta, we were concerned about infected seed, and it was a legitimate concern, quite frankly, especially in areas outside of southern Alberta. Planting infected seed resulted in infected seedlings. The research that we did in the early 2000s demonstrated the fungus could go from the seed to the subcrown internode to the crown tissue and up to about the third node. So it established a source of residue that then, if you followed a tight rotation, highly susceptible variety, you'd quickly build up that amount of infected residue. Now, if we look at the disease cycle, these sexual fruiting structures are the key structures that produce spores that are shot up into the air like cannonballs. They're carried by wind currents and they land on that cereal head, and the infection occurs after full head emergence and takes about 10 to 14 days under ideal conditions where you're going to see symptoms, and then the production of infected residue, which then serves as a source of disease in subsequent years. If we're looking at the forecasting system, we're really looking at the impact of those temperature and moisture parameters on production of the sexual fruiting structures, production of spores, and then the potential for those spores when they land on that cereal head to germinate and infect that head tissue. So if we look at the temperature parameters, and you need moisture, so you'd need damp conditions down on the soil surface, but in terms of temperature, the production of perithecia can occur from about 15 to 30 degrees C. It can be as low as 5, but typically the production is very low. If we look at ascospore production, it's anywhere from about 13 to 33 degrees Celsius, so fairly wide temperature range. Dispersal of the ascospores anywhere from 13 to 23 with an optimal of 16 degrees Celsius. In terms of infection, so we have these perithecia releasing ascospores landing on the cereal heads, and within 48 to 72 hours with rain or dew or high RH above 90% and temperatures in that 10 to 30 degrees C range, we have the potential for infection. Now, the lower temperatures simply mean that you need longer periods of leaf wetness or head wetness, longer periods of high relative humidity. When you're in that 25 degrees C range, that infection is going to occur much more rapidly. So in cooler conditions, typically you need longer periods of moisture. And then you get symptoms within 10 to 14 days, depending on weather conditions, depending on the susceptibility of the variety, and so on. Now, in terms of infection, and this relates to spray timing, don't get hung up on flowering. That's one take-home message. Don't focus on that. Anthers have been identified as potentially being part of the infection process, but the research going back to the 1920s and 30s illustrate that you don't need anthers present for infection to occur. An infection can actually occur anytime from head emergence through to the start of senescence. So that wide window for infection means it's very, very difficult to get effective management of FHB using a fungicide. So if you look at Fusarium damaged kernels, which are more of a grading factor in wheat and durum wheat, the most severe development of FDKs and potential for downgrading are if infections occur close to flowering or shortly thereafter. That's where you're going to get the most severe symptoms. As that infection occurs later on during the grain filling period, especially late milk and towards the start of senescence, you can have infection, but it's superficial infection. The kernels look healthy. The grade probably isn't impacted, but the fungus is still there, and most importantly, the deoxynivalenol is there, and that can be at levels that are well above the 1 part per million sort of threshold that we have for malting acceptance, human consumption, and consumption by swine. Dawn development basically can occur right from the point of infection and head emergence through to the start of senescence. So that's why, especially in barley, trying to get your dawn levels down below 1 part per million can be very, very challenging. And I've got wheat here, but basically, if you get earlier infections in barley, you get some shriveling of kernels, but not to the same extent as you do in durum wheat or spring wheat. What you'll get is a lot of discoloration, which the maltsters will pick up when they're evaluating your barley for malting status. The higher the discoloration, the greater potential for microbial load, which can cause problems in the germination beds and in the brewing process itself. You can also see, if you look closely, production of that sexual fruiting structure. You can see that on barley tissue even before you've combined it. Now, if you have infections that occur later, those barley kernels might appear bright, clean, uninfected, but that superficial infection is still there and your dawn levels are still there. So how do we deal with this sort of difference in maps? And I like to look at the best case scenario and worst case scenario. That's sort of easy to look at. So if we have low risk where you likely do not need to spray for Fusarium Head Blight, keeping in mind that you've got leaf diseases that might be a concern. So your risk levels are low for wheat, barley, durum. That's a situation or a scenario where likely the benefit from that fungicide application for Fusarium Head Blight is going to be minimal. Conversely, if the risk levels are moderate or higher for all of these different crop types, if you put that into the tool, that's a clear indication that you're in a scenario where you need to put that fungicide on. Where things get more challenging is where it's in the middle. And my philosophy and recommendation to you would be to look at kind of the combination of factors. So if you're seeing moderate to high or higher risk in your wheat on your farm, your barley is maybe in that low to moderate, chances are, based on the impact of those weather conditions and temperature and moisture on perithecia production and ascospore production and potential germination of spores and infection of heads, you've got an issue that you probably need to take care of. Now, I like to look at simple tools, and one that comes out of some experience that I've had advising some growers. I visited a seed farm, Con Seed Farms outside of Red Deer, there to talk about Fusarium graminearum and Fusarium Head Blight. Mr. Con said, well, we're just about close to thinking about spraying for Sclerotinia in our canola. Can you come out and look at our crops? So I did. And basically we went out, and it was about 10:30, 11 in the morning. The soil surface was bone dry. The crop canopy was bone dry. Our boots were dry. They're not muddy. Our pants were dry. That is a clear situation where there is limited risk of disease. In this case, it was sclerotinia, but it would apply for leaf diseases in cereals and for Fusarium head blight. Conversely, if you go out to that same field in the afternoon, 4 o'clock in the afternoon, the soil surface is sopping wet. Your boots are wet and your pants are wet well above your knees, and you've got moisture throughout that canopy. That would be a scenario where the environmental conditions are definitely conducive to disease development. So very quickly, let's put it all together. So I'm going to give you a bit of philosophy as far as assessing leaf disease risk and when to spray and when not to spray. So again, you can be out during herbicide timing. Take note of what's there. Do you have an emerging problem that you need to take care of when the upper canopy leaf tissue is starting to emerge? It's not the best target in terms of fungicide application unless you're seeing stripe rust. If you're seeing stripe rust, especially in your wheat, at that herbicide timing, you'd better go in with a fungicide. And it's the nature of the rust. They're biotrophic pathogens. They don't kill plant tissue in order to derive nutrients. Conversely, leaf spot diseases like tan spot, septoria, net blotch, scald, spot blotch, all release toxins and enzymes depending on the fungus. And those kill plant tissues, and that fungus lives on that cell content. So the normal water conducting tissues are no longer functioning. Conversely, in stripe rust, because it doesn't kill that tissue, the fungicide has a much better ability to get into where the fungus is and to actually have an effect on it. So one aspect that you might look at if you're concerned about early season leaf disease development, and we did some work back in 2013 through 2016, and it came out of some exposure to seed treatments and the potential role for foliar disease management when I visited Australia in 2012, and especially colleagues at Horsham, north of Melbourne, about 3 or 4 hours. So some of the seed treatments, most of the actives, if they move, if they have mobility in that plant tissue, they will move with the water transpiration stream. So they'll move from the seed to the first true leaf, to the second true leaf, to the third true leaf. So seed treatment, if you are concerned or you have clients that are concerned about early season development, potentially consider a seed treatment. If you're seeing lots of disease at herbicide timing, you see it continuing to develop as you get into stem elongation and emergence of things like the penultimate leaf, the third leaf from the head, that is a clear indication that you're going to have an issue. Our rule of thumb for barley especially, and it would also apply to wheat, is we look at the third leaf from the head around flag leaf emergence. And if we're seeing more than about 1 to 2% of the area of that third leaf from the head with symptoms, chances are you're seeing a lot more further down towards the soil surface in that plant canopy. That is a clear indication that you need to spray a fungicide, either at flag leaf emergence or if it's really high, potentially when that third leaf from the head is coming out a little earlier. Now, if we go out and we don't see much disease development, herbicide timing, we really don't see much around emergence of the third leaf, the second leaf from the head or the penultimate leaf or the flag leaf. That's a clear indication that we can probably delay and wait until head emergence to put on our fungicide that gives us our FHB and dawn suppression, but also provides us that leaf disease control. But that's a perfect world. We don't live in a perfect world. You're challenged by leaf diseases, so you're going to have to look at spraying potentially before flag leaf emergence, or head emergence, I should say. And again, look at what's developing in the crop. And Mitchell alluded to it. Fusarium head blight and sclerotinia and canola are very similar. You need to make the decision to spray before you see symptoms. I love working with cereal leaf diseases. You can follow what's happening in the crop and use what's happening to give you key information to decide when I need to spray and if I need to spray. So again, in that situation, you may need to look at a pre-head emergence application to manage that leaf disease, and then come back in at post-head emergence to top up your leaf disease control and to give you some FHB suppression. The one thing I want to emphasize is that if you see a lot of leaf disease development before head emergence, and our recent research under the barley cluster and CAP from 2018 to 22, and the wheat cluster during that same period clearly illustrated, if we have an emerging leaf disease problem prior to head emergence, we'd better put on a fungicide before head emergence. If we delay, we're going to compromise the level of efficacy of that fungicide. The other thing I want to talk about is timing. And the current labels for fungicides for FHB start much too early. The research, whether it's Randy Kuchar, our recent research under the barley and wheat cluster, a lot of the research out of the US clearly indicates that you want to wait until full head emergence, and that the research that we've done, that Randy's done, that out of the US, illustrates that you don't pay a penalty if you delay. In fact, it actually may have a benefit in terms of dawn management. So how do we use the risk maps? Well, I would recommend starting to follow them at flag leaf emergence. Not a time to put on that fungicide, but if the conditions, you're really looking at the production of parathecia, the production of ascospores, and whether the fungus is going to be in the air when your cereal heads come out of the boot. So if you're following the risk maps and the risk is low from flag leaf emergence through booting to head emergence, that might be a scenario where you don't need to spray a fungicide. Keeping in mind, you also may have leaf disease issues that you need to take care of. The opposite end of the spectrum, if that risk level is high right from flag leaf emergence through to head emergence, this might be a scenario that you'd want to get in as soon after full head emergence as possible to try and get the best level of suppression of FHB and dawn as possible. Where things get more interesting, if you transition from a low risk to a high risk, so low risk at flag, high risk at head emergence, look at the next 2 weeks in terms of the weather forecast. But this might be a scenario where you can delay to the mid to the latter part of that current label application window. What's even more challenging is if it starts off at a high risk and then transitions to low. This is a tough call. I would look at what the forecast is for the next 2 weeks. I would look at what your previous experience with Fusarium Head Blight has been, whether you've had issues with downgrading and dawn contamination, and if you're advising a farmer, what is their risk aversion level? And they may be very risk averse. I don't like to take chances. And they may find some peace of mind in terms of spraying a fungicide at that time. And I'm going to end there, and I just want to leave you with one message. Again, awareness, regular disease surveillance, and crop planning will definitely provide you with a better ability to manage surprises. I'm involved with the Prairie Crop Disease Monitoring Network. There's lots of good information on the network in terms of cereal disease management, risk assessment, and so on. So please consider visiting it. We're also on Twitter. I will share with Mitchell a PDF copy of this presentation. I'll probably add a few more slides to emphasize the timing aspect in relation to leaf disease and FHB management. And Mitchell, you're more than welcome to share that. And I think I'm ready for another beer. So any questions? So the question was in terms of our temperature parameters for FHB and the current risk maps that we have are between that 25 to 28. Is that focused on Fusarium graminearum only, or how does it relate to some of the other Fusarium species that might produce dawn? And the other main one that is Fusarium culmorum. It doesn't produce the wind-borne stage like Fusarium graminearum. It's more of a root and crown disease issue, so you don't necessarily see a lot of head infection. You'd have to have a lot of rainfall to splash the spores. The asexual spores are produced in masses of spores that are splashed by rain splash. So you'd have to have a lot of moisture. The temperature parameters for calm warm might not necessarily be as warm. You look at other species of Fusarium like Poe, it tends to be the one where it's a hot, dry summer. We tend to see more Poe than we do Fusarium graminearum. The other thing is that if you look at the years that Paul Bullock and colleagues looked at developing their model, it was basically 2019 through 2021. So fairly dry years, certainly 2021, higher temperatures. So that may be a factor. Certainly Paul is very active in terms of refining the model. He's talking to us and colleagues like Hiroshi Kubota. We've got a number of trials across the prairies to try and utilize some of the barley data. We're going to look at dawn and then the weather parameters. So they're constantly going to be refining that model. Looking at the range from the states, it can occur over a fairly wide range. But I would say your parameters that would be most concerned would be in that 20 to 25 degrees C. If you get above 30, your daily highs above 30, those are conditions that may not necessarily be very conducive to Fusarium head blight development. So my email's there. Certainly send me an email. Send me digital pictures. We do a lot of digital diagnosis over the course of the summer. And if you have any other questions that you want to ask, certainly shoot me an email. Or I'm a bit shy, so come to me. And if you can bend my ear, like I said, I might need another beer right now. So.
Thanks very much, Kelly. I do have a few wrap-up comments from SaskBarley. Once again, want to acknowledge everybody here at the Dam Smokehouse who have been really helpful here tonight and served as a great meal. And like Kelly alluded to, some very nice craft beer. And then also to presenters, Aaron, Chris, and Kelly, thanks very much for coming out. Thanks everybody for coming out and staying here for the evening. I think we've had some great information come from our presenters. Thanks to the production team and to SaskBarley staff and directors here tonight who've been supportive as well.